So my name is Andrew, and I want to introduce some of the rest of the teaching. And so the first of them, and the most widely used one, is supervised learning.
Imagine we have a bag of fruit and we already know the name of each fruit inside. Every time we pick one fruit, we can immediately say its name, like it's an apple or it's an orange. This process where we know the correct answer or the label is called supervised learning.
Okay guys, here we have a data set with three columns. First column is size, second column is color, and the third column is the name of the fruit that we call the label or the response, our response. Third column depends on these two first columns. So whenever we have this label in our data set and we train a model to predict the label from the features, predict this from this guy. We call this process supervised learning because we have these columns. Supervised learning. You have data with labels and the model learns to map input to output. Example: predicting houses price from size and rooms, or recognizing fruit by size, color, and the name. More accurate because you know the correct answer. Means label data, which can be a pain to collect. Unsupervised learning. Data has no labels and model tries to find pattern or cluster by itself. Example: grouping customers by shopping behavior, or sorting fruits by looking without knowing their names. No label needed. No label data needed. Output can be weird sometimes. Needs human interpretation. Chill summary. Supervised is like having a teacher telling you exactly what's right, while unsupervised is like staring at a bunch of fruit and figuring out which ones look alike on your own. One guided, the others flowing.
So what I want to do today is really go over some of the major categories of machine learning tools and sort of what you learn in the next by the end of this quarter. So the most widely used machine learning tool is today is supervised learning. Actually, let me check. How many of you know what supervised learning is? Like a 2/3, half of you maybe. Okay, cool. Let me just briefly define it. Here's one example. Let's say you have a database of housing prices, and so I'm going to plot your data set where on the horizontal axis I'm going to plot the size of the house in square feet, and on the vertical axis we'll plot the price of the house, right? And maybe your data set looks like that. And so horizontal axis, I guess we'll call this X, and vertical axis, we'll call that Y. So the supervised learning problem is, given the data set like this, to find a relationship mapping from X to Y. Right? And so, for example, let's say you're fortunate enough to own a house in Palo Alto, right? And you're trying to sell it, and you want to know how to price the house. So maybe your house has a size, of that amount on the horizontal axis. I don't know. Maybe this is 500 square feet, 1,000 square feet, 1,500 square feet. So your house is 1,250 square feet. Right? And you want to know, how do you price this house? So given this data set, one thing you can do is fit a straight line to it, right? and then you could estimate or predict the price to be whatever value you read off on the vertical axis. So in supervised learning, you are given a data set with inputs X and labels Y, and your goal is to learn a mapping from X to Y. Right? Now, fitting a straight line to data is maybe the simplest possible learning algorithm, maybe one of the simplest learning algorithms. Given the data set like this, there are many possible ways to learn a mapping, to learn a function mapping from the input size to the estimated price. And so maybe you want to fit a quadratic function instead. Maybe that actually fits the data a little bit better. And so how do you choose among different models will be either automatically or manual intervention will be something we'll spend a lot of time talking about. Now, to give a little bit more, to define a few more things, this particular example is a problem called a regression problem.
Next up, regression. It like and help science grow.